go over this 2025 AMC 10 question number 24. Call a positive integer fair if no digit is used more than once. No digit is used more than once. That means no repeating digit. It has no zeros, no digit adjacent to two greater digits. For example, 196, 23, 12463. These are fair integer. But these number 1546, 329, and also 34321 are not. How many fair positive integers are there? We have 5 choices. Based on the description for the fair integers, we can see the good example. 196, you see 1 going up to 9, and then 9 going down to 6. That means we have the largest number on the top. 23, 3 is on the top. And then for the next number, 12463, you can see all the way from 1 go to the very top for the largest one, and then going down. You probably already see the pattern. We're gonna describe it in a moment. Let's also see the bad example. So the bad example, you can see these are 3 numbers. One is 1546, 1546 is going up and also going down. And then you're gonna going up again. This one, instead of we have the top points, we have the lower points too, 329. And next example, everything looks good except the 3 has been used twice. So we already see this pattern. Look at the good example. The first one, we have the mountain top. We had 9 for the first one. You're climbing up and then going down. The second one, we have 2, 3. You're going up 2, 3, and then you're gonna know where to go, just going to the top. The next example, you're gonna go from very bottom, go to the top for 6, going down to 3. So these are a mountain top for these numbers. Let's take a look at the bad one. There's no such a thing called mountain top. And even though the third one, we do have the mountain top, but the thing is, there's a repetition for 3, that causing the trouble. For the other 2, there's a valley over there. Instead of mountain top, we have like a valley. This has a valley, and also the second one also has a valley at the point 2. The first one, you can see 4 is on the valley. So we can conclude it right now. Fair integer has 1 mountain top. The left-hand side is going up, like increasing. On the right side is decreasing. Sometimes we not have the left-hand side or right side. Maybe just one side, like a 23. Just stop on the mountain top and then stop there. If we have something going down, that will be decreasing. The left-hand side increasing, the right side decreasing. So we see such a pattern right there. We may not have the left-hand side or right side. So it may have only left or only right. Let's see some example for the simple one. Let's say the mountain top, we have the number start with a 2, and then the only one left you can put is 1, or you can put a 1 on the right side. Or you don't select the 1. So you have the 3 cases. If we use the maximum number, which we call the mountain top number, is 2. In that case, the only one less than 2 is 1 for the non-zero number. So we can put on the very left-hand side like this, or you can put on the right side, okay? And then or you choose nothing. You don't choose the 1 at all. So therefore, we have 3 cases, 3 ways to arrange this. So only one number less than 2, we can put a 1 on the left or on the right, or I put a 1 nowhere. So therefore, we got a 3 way to construct such a number with the maximum digit is 2. If I have the 3, what should we organize this one? So the number, if I put a 3 on the very top, and then 1 and a 2 are the 2 number less than 3. I'm gonna consider first case, 2 is on the left-hand side. I put a 2 on the left-hand side of 3. And in that case, the number we can put there will be 1. But we can put a 1 in 3 different ways. 1 you put on the very left-hand side, but you cannot put between 2 and 3 because we want this one increasing order, no value on the left-hand side. The second case, we're gonna put a 1 on the right side. And then the third case, you can see simply just, I don't take 1 at all. So you get a third case. So in that case, if I put a 2 on the left-hand side of 3, we can construct the 3 different numbers, which are fair numbers. This is gonna be the 3 result. What about if I put a 2 on the right side? And then we can do the same thing. 1 can put on the left-hand side of the 3 or right side of 3, but right side of 3 you can only put after the 2 because it has to be decreasing. Or I don't take the 1 at all for the third case. You can see for this one, I even don't take a 1 here, just the 3 and the 2. So we still get the 3 result then. What about if I don't take the 2 at all? That's independent, just the 3. So in that case, we still can put a 1 on the left, on the right, and we take no 1 like this. I can put a 1 on the left-hand side. You can see left-hand side and also right side. And then I don't take 1 at all. So we still get 3 results. So based on this, we can see you got these 2 on the left. You got 3 cases. 2 on the right, we have 3 cases. I don't take the 2, we have 3 cases. Therefore, we get a 9 way to arrange this number to get the fair integers with the maximum digit is 3. And then we take care of this. Okay? These 3 cases just completely take care of everything we needed with the mountaintop number 3. 3 is like 3 times 3, 2, 3 multiplied together. Where the 2 we can understand that will be 2 number less than 3. So 3 times 3. Let's see the general case. If the maximum digit is n, that means the mountaintop number is n. So the available number less than this n can be from 1 to n minus 1. Each of these numbers you can put a left-hand side of this n, or you can put on the right side of n. Or I don't take this m at all. So each of the digit, there's 3 choices. Put on the right side, put on the left-hand side, or it is not selected. So that's totally 3 cases. So therefore, we have 3 ways for each digit, which is less than the maximum digit m. Once the digits are selected, they are automatically ordered on each side because they has to be in increasing order, so there's no extra arrangement to be considered. So therefore, we have how many ways to do this with the mountaintop number n? We have the fair integers. We have 3 to the n minus 1 results. 3 to the n minus 1 means 3 times 3 times 3. We have n minus 1 choices right here. You can see n minus 1 choices right here. 1 to n minus 1. So that's mainly we have to consider all of these cases right here. and each one associated with the 3 way to do this, I have n-1 results then. So the total will be 3 to the n-1 way to get the fair integers. So each n we get these results. So altogether, for each digit in this set, the n can be from 1 to 9 because 9 is 0 digit. So each one has 3 to the n-1 way to construct it. So therefore, we can just sum them up, the total number of ways to get the fair integer. We can conclude it. We just add all these up to get 1 plus 3 plus 3 squared plus 3 to the 8 power. These are the geometric series. We just add them up. You get a 3 to the 9 minus 1 divided by 3 minus 1. This is the way to get the geometric series sum. And then you're going to get the answer, 9,841. That's the solution then. Thank you.